between methane and between methane and temperature. So there is and between carbon dioxide and temperature. So there's a direct correlation between the temperature and the sea levels. Okay, so the warmer it gets, higher the sea levels get because glaciers melt. Okay, so melting of the glaciers is what causes it. Okay, so that shows you comparing CO2, methane to temperature, and you can see how they're directly correlated. So you see where the CO2 peaks, and so does temperature, right? And that's where the sea levels also rise. So sea levels rise because the weather is getting warmer, and we talked about it's part of normal temperature. There's a certain amount that's normal and natural that the environment, it kind of happens in the environment, and then you have the part where because of humans we've accelerated it. The graph shows you the orange is the average annual temperature, the mean, and carbon dioxide. So as you can see, there has been a great increase in carbon dioxide concentration from 1880 to today. Okay, and so there is a direct correlation between the levels of CO2 rising to temperature rising. So there's no way to deny global warming, right? You can't really deny it. It's right there. Yes?
What would the slope of this line be if humans weren't impacting it? Do we have any projection of where we should be?
You probably wouldn't have this peak right here.
Where would you expect it to be?
Okay, so it would have been kind of at this level and continuing on. It might have a peak at some point, but not within a 30 years, not within a 40-year period. Maybe within 100,000 year, but not 30 or 40. Yeah.
So then, what's like with that steady increase? Why is there that huge peak on 10 years? Like in
the black line?
So like there's that steady black line until it peaks, but the red line and the orange, it like jumps up in the middle of the steady slope.
Temperature and
like that little hump.
This?
Yeah.
Oh, why did the temperature go up at that point?
Yeah.
Industrial Revolution, is that the time?
We got a little bit better at dealing with it, and then we got a lot worse.
Yeah. Probably cars being produced a lot more at that time, industries and such. Okay, so
really inefficient cars.
Oh, very. 1960 to 2009 CO2 concentrations, again, they're measured by ppm, parts per million. There's also a measurement called ppb, right, parts per billion. So obviously, the higher that number is, the greater the concentration per million, per million particles in the air. So out of the million particles, 300 of them is carbon dioxide. That's too many. That's way too much carbon dioxide for the health of the earth. So, where do we play a role, right? So the IPCC, which is the Intergovernmental Panel on Climate Change, and here are their 2010 updates. So the textbook is a little older, so it's 6 years behind, but it gives you a pretty good idea. 90 to 99% likely that lower atmosphere is warming, especially since 1960, mostly from human-caused increase in greenhouse gases. Earth's climate is changing from increased greenhouse gases, and because of this, it's going to trigger a significant climate disruption this century. Ecological, economic, and social disruptions, because every time you have some kind of climate disruption, right, you can also have social and economic problems as well. If you have a tsunami or a tornado where you're not supposed to, a hurricane when you're not supposed to, something like that, causes a lot of damage, and that's a lot of economic disruption. That's what they're talking about.
Yeah, but that's different than like the drought.
What do they do to help? Okay, the question is, what do they do to help? There's really not much you can do for the climate change at this point, except to try to decrease the carbon dioxide emissions. That's it. There's really nothing else you can do. So 1906 to 2005, there has been an increase about 0.74. 70 to 2009, there has been the annual greenhouse emissions have been 70% human caused, and it's been the warmest decade has been from 2000 to 2009 since 1881. And the past 50 years, Arctic temperature has gone up almost twice as fast as the rest of the year. So then we have melting of glaciers, last 100 years, sea levels went up about 19 centimeters. 2.5 centimeters is an inch.
A little off topic, still on topic though. For gases, is there really no way we can go up and collect like particles in some way? Do you know what I mean? There's nothing to do.
Nope.
Nothing to do.
Mm-mm.
As of now.
As of now. Right, exactly.
Time travel pulls a person and invents. It starts the Industrial Revolution.
All right, melting of the glaciers compare 1948 to 2004. And what you see there as being just ice
What's
is
on the
now
left?
all melted.
That's ice on the left?
So looking at this, again, 1979 to 2007, that's really not that long in Earth's history when you're talking about the Earth's history, you know. That's not really a very long time. And as you can see, it's getting smaller, right? And the floating sea ice is getting smaller because it's just melting and temperatures is rising. So there's really no way to deny global warming. So it says what would happen with 2 degrees Celsius warming with 450 parts per million? What would happen if we had 3 degrees Celsius or 4 degrees? And those are a list of the things that are going to happen if we have a 2-degree change. Coral reefs are affected, crop yield falls, there's a lot of conflict over water supplies. If it's 3 degrees, it's going to get worse. Like, for example, malaria and other tropical diseases get even worse because in the warm weathers, they grow a lot
Mosquitoes.
faster. And yeah, you got a lot more mosquitoes and such. Amazon rainforest may actually begin collapsing if it goes up by 3 degrees. If it goes up by 4 degrees, you have tropical diseases spreading even faster. Glaciers are melting. At least half of the plant and animal species face premature extinction.
Why is it that we're so close to this line?
What do you mean?
Like,
Why are
3
we-
degrees really relatively isn't that hot, right? Relatively. I know on the Earth
Oh, right.
it's gigantic, but
Uh-huh.
why are we so close to that?
For melting of glaciers, it's a problem, right? Because
Well,
they
yeah,
start
but-
melting at a faster rate. Fish have very low range of tolerance. It's a problem. Plants can't handle it.
Plants can't. A couple degrees. I don't know. I thought it was like 10 or 15 for plants. At least.
10 or 15 is a lot.
Well, 10 degrees is a lot.
Yeah. All right, so 2,500 scientists working for over 2 decades. And of course, we still have a problem, right? Because we don't have a great model. There's a lot of debate. You still have a lot of people who don't believe global warming, and you have really no solution. Okay, so human factors are the major cause of temperature rising in the past 30 years. And there's always uncertainty with any scientific model, and that's why you have a group of people who don't believe it. So that's a model of some major processes that interact to determine climate. Right? You have greenhouse gases, cooling from ice and snow cover. It says increasing, and you can see the land and soil and all the changes that take place.
There's really nothing we could release to make it so gas gets out faster or like heat escapes. Like in
Not
the
if we
same
have
way-
the greenhouse gases,
No, but
then
in
how
the
are you
s-
going to have it escape?
No, in the same way that greenhouse gases made it so the Earth is warmer, there's nothing we can release to make the
Oh, cooler? Mm-mm.
how to exploit that.
Because heat is what is released. And
Nothing would lower the temperature though. It's impossible to do so.
all your
Even
energy
by
is coming
releasing
from the
really
sun.
slow moving molecules.
How are you going
To like absorb all the
All right. Comparison of the change in temperature 1860 to 2008. Again, you can see there's an increase, and it's projected to increase even more in the next 100 years. Okay. You can read about James Hansen and what he did. So, burning fossil fuels causes obviously CO2 emissions to increase, and those are the projected numbers. By 2100, they expect the parts per million to be 1390. And look at the tipping point. What's the tipping point? 450. Where are we? Very close. The largest emitters as of 2009, China, US, European Union, that includes about 27 countries. Indonesia, Russia, Japan, and India are the top 7 CO2 emitting countries.
Are China and the U.S. ahead by a lot, or?
I don't think so. But China's population is triple that of US.
That was also 7 years ago.
And that's also 7 years ago, exactly. So these are cumulative CO2 emissions from 1900 to 2005 in billions of metric tons. And of course, we like to lead in these kind of things. Burning any fuel creates heat, and many sources of heat are the power plants, internal combustion engines, those are your cars, and lights.
Put a giant air conditioner on.
Mm-hmm. Researchers think atmospheric warming not due to an increase in energy output from the sun since 1975. Troposphere has warmed, but the stratosphere has cooled. This is not what a hotter sun would do. But it's not that. The problem is the heat that stays. And then the oceans, solubility of CO2 in ocean water, it absorbs when the ocean water gets warmer, then it absorbs less CO2. So then the atmospheric warming even becomes worse. And that affects phytoplankton. You know what phytoplankton are? Mm-hmm. What are they?
What the plankton? I don't know.
What are plankton?
They're microscopic plants.
I'm guessing it's like the bottom of the food
sunlight
chain.
to make energy.
Or like the
And they're
base.
eaten by fish.
Thank you. So phytoplankton, little
Are those just
microscopic
really-
plant organisms, right?
Are they
That are at the
really-
surface of the water, and they can absorb the sun's energy, go through photosynthesis, and then fish can feed on them. So if you kill the phytoplankton, you really destroy the ocean's food chain.
What
Okay.
is the animal that has a good light? The fish? Yeah, Finding Nemo has a good
Oh, the
light.
bioluminescence fish? I don't know what they're called.
I think it's an anglerfish.
They have a light.
Yeah.
Cool.
That's because they have chemical reactions in their body that create light because they live in very dark areas. They have no other way to get light.
Plus it attracts prey.
Because it's
Yeah,
just
it's an
chemical reactions within the cells.
How's
See?
it fish? How does it like fish made it?
Evolution. Alright, warmer temperatures
also
also
doing
create
worms.
more clouds. Okay. And so cirrus clouds at high altitudes, and then cumulus ones are low altitudes. So that's what that looks like. Cumulus and cirrus. There's more than. There's more than. Yeah. Outdoor air pollution that can temporarily slow global warming. So certain pollutants will not enhance projected global warming, but they'll fall back to the earth or are washed out of the lower atmosphere. And in developed nations, you have a lot more of them, like aerosol. So, possible effects of warmer atmosphere, we already know. Worst case scenario is this. Prolonged drought, more destructive storms, low-lying cities being completely flooded, wildfires, ecosystems completely collapsing, glaciers shrinking, rivers drying up, extinction of half a world's species, and spread of tropical infectious diseases.
These are just the worst case scenarios.
These are things that are already happening, by the way.
Yeah,
It
we
sounds like every case scenario.
So, you have more droughts, which we already know that in LA. We have dry lakes, lower water table, dry climate ecosystems will increase, and lack of water in general is a problem, obviously, you know that. And why would it be worse in the polar regions? Well, because now you have, it says 99% of Alaska's glaciers are shrinking. That's pretty much all of them. And when mountain glaciers disappear, there's going to be a lot less water in major rivers. So then that affects every other ecosystem.
Like the Colorado River, the Mississippi River.
All rivers.
What's that 1% of the glaciers that are just like, no, I'm not gonna move?
They're probably in regions where it's not.
Can you create glaciers within a map?
No.